Hi everyone, today we are going to talk about the actual gradient boosting machine and the mathematics behind it. But before that, I assume that you have gone through the intuition video for GBM. If no, then I request you to please watch that first before watching this particular video. So this is the algorithm which Friedman has given in his original GBM paper. So let's talk about input first. So he's saying that we require a data which contains certain x's. So let's say this is my age, this is height, this is color of their eye, and so on, and the y, which is the dependent variable I require for observations from 1 to n. So this is what essentially this funky looking equation is telling us. Then we need a differentiable loss function. Why differentiable, that we'll see in a couple of minutes, but we require a loss function which can be differentiated. So in case of regression, you might have got from linear regression that the loss function which we deal with is basically sum of predicted minus actual values, right? And it's square. So in case of GBM, we are going to modify it a little. We are going to add half in front of it. So that doesn't matter whether I minimize predicted minus actual square or I minimize the half of that. The results are same, but it makes our life easier if we include half over here for GBM, right? So it's a loss function, and obviously it can be differentiated. So I get it, let's say with respect to predicted. So in that case it will be it will be 2 by 2 predicted minus actual, right? So this is what we get once we differentiate this. Okay, so now let's go into the algorithm and see what this step 1 is doing. So it is saying that initialize model with a constant value f naught x. So we had initialized our model with f naught x, which was nothing but mean of y. Let's see why did we took this mean of y. So as per algorithm, this f naught x should be something which minimizes my loss function. So this equation essentially saying is that we need to find that value of gamma which is minimizing my loss function. Okay, so again writing down my loss function. So this was my loss function. Now I want to find that value of p which minimizes this overall equation. Okay, so by using laws of mathematics, if I differentiate it with p and equate it with 0, this should give me the minimal value of L, right? So basically it will give me the value of p which minimizes L. Let's try to do that. And so if I differentiate del L over del p, I get 2 times 1 by 2. So this power comes out if I am differentiating, right? Then this entire quantity remains the same, right? So this and this will get cancelled out. So this is basically summation from I equal to 1 to n. Now if I equate it to 0, I get summation of p minus a pi ai equals to 0, right? Now so essentially what we are saying is that p minus actual value of 1, p minus actual value of 2, plus so on up to p minus an, plus I have n observations, and I am equating it to 0. So I can write it in a simpler fashion where I take out all these p's, because p is same across all the observations. and so on equals 0, right? From here I can get a1 plus a2 plus dot 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 divided by number of observations. So this p, which minimizes my loss function or the initial value of my model, is nothing but average of all the observations, right? So this is where we initialized our predictions with a constant value, which was mean of all the actual y's. For our example, it was 64.67, nothing but the average of all the y's. So we have seen that essentially this is saying that this is nothing but the mean, right? Now let's come to step 2, and first let's get into this sub step of 2, where it is saying to calculate RIM with this funky looking symbol. Okay, so let's see what is it essentially saying is. So my loss function is again 1 by 2 predicted minus actuals whole square, and obviously summation is there, right? Now it is essentially asking me to differentiate this loss function with predicted value over here. So let's do that. So I will get 2 times 1 by 2 predicted minus actual, right? So this RIM over here, which we are seeing, are nothing but residuals. I is nothing but for each observation, and this M over here is nothing but for mth tree, right? So by putting into this equation this minus sign, I've got it from here, then this equation, this is predicted minus actual, and if I take care of this minus, then this becomes my actual minus predicted, which is nothing but our residuals, right? So basically we have initiated our model with the mean, and now we are going forward and building subsequent trees. So we are going to build capital M trees. So this is for first tree, we are calculating these residuals, which are nothing but actual minus predicted, right? In the next step B, it is just saying that fit a regression tree to the RIM values, which are nothing but residuals, and create terminal regions for J1 to Jm. So this is nothing but saying is that build a small tree in such format right. So first I have split it on age, then height, and there I have R1, R2, R3 residuals for all those guys who came in this node. Similarly, I will have some residuals here and some residuals here. So this is what we have done till now. So terminal regions are nothing but these and leaves of the nodes. This is what essentially it is saying, and these J's are nothing but these splits which we have made. Okay. So till now we have understood that this is a loss function we are using for our example. We initiated our model with mean value of y's, and my residuals are nothing but actual minus predicted values. Next we fit a decision tree on these residuals. So for example, I have split it on age. So wherever age is greater than 25, I have got these two residuals, and wherever age is less than or equal to 25, I got these two residuals. Next, what it is saying is that for each of these three, we need to find out the value of gamma such that it minimizes this particular function. So this particular function is nothing but again. So I have my, so now my predicted value becomes f naught, which was the previous prediction, which was nothing but average in our case when we initiated it, plus the gamma, which we need to find out of this, minus the actual value, right? Now, and it's square. This f naught is constant, so let's say this is 65 for example, plus gamma minus actual values, it's a square. Let's differentiate this del L by del gamma. I will get 2 times 1 by 2 summation of 65 plus gamma minus actual values, right? Now, and I can cancel out these two. Now again, in order to calculate the value which minimizes this L, I need to equate it to 0. That I can do simply 65 plus gamma minus actual equals 0. From here I can write 65 plus gamma equals actual. This is again summation. So from here gamma is nothing but mean of actual minus 65, right, when it was the first tree. So essentially what we are saying is that the gamma for this case is nothing but R1 plus R2 plus R3 by 3, which is nothing but mean, and here it is R4 plus R5 by 2, which is again mean for this case. Okay, so this step is done. Okay, so my gamma now becomes average of residuals in each split, right? So this is what I've got. Now the last step is saying that you need to update the prediction of current model with prediction from last model plus shrinkage parameter times the gamma value you have received, right? So this is, so essentially my new prediction becomes the previous prediction. In this case it's f naught plus this new, which is nothing but shrinkage rate or learning rate, times gamma value for that particular observation, right? So this becomes output from my first tree. In a similar fashion, I can go for second tree. I can calculate these residuals again, fit a regression line to those observations using residuals, and calculate gamma, which minimizes this loss function, which will be mean, right? And update my model. Okay, so if you would have observed, then this loss function and this loss function are pretty much the same, right? So essentially what we are doing here versus here are exactly same, except this gamma which we had earlier now becomes previous prediction plus the gamma value. So this will be again the mean of this, which will minimize my this function. Okay, so For our case, we had used this loss function. You might use some other loss function, but keep in mind that it has to be differentiable. Then you are allowed to use it, but essentially the steps remain the same. So I hope you got an idea about the mathematics behind gradient boosting trees. Why do we use averages while initializing the model, and what do we do with the residuals for the next trees? So thanks for going through this tutorial. We'll see you in the next tutorial. Thank you.